Good morning, majors. So today we're going to look at a new chapter. It's called Unit 7. This is day 1, and we're going to look at right triangles. The first part should be a review. We should do most of this during the warm-up. Try plugging it into the calculator to check to make sure you did it correctly. This one, dividing by a radical, I'm not sure if you guys have seen this before, but when we have a square root in the denominator, which means the bottom, this is called the denominator. We need to rationalize it. We don't leave square roots in the bottom, in the denominator. So whatever square root is in the bottom, we're going to multiply the top and the bottom by that square root, which in this case is the square root of 3. 15 times the square root of 3 is just 15 square root of 3. And then square root of 3 times the square root of 3, you can remember that we did this during the warm-up. A square root of 3 squared, the square roots and the squared cancels each other. So we just have 3 in the denominator. And now I can actually simplify this. Not always can you simplify it, but in this case I can, because 3 does go into 15. We cannot divide 3 into the square root because this one does not have a square root. They're not like terms. But this is a whole number, this is a whole number. 3 goes into 15 5 times. So we have 5 square root of 3's, and you can put that over 1 or just leave it like that. It's fine. Practice simplifying the following radical expression. What I like to do in this case is make a tree, and I'll just pull whatever is in the underneath the square root. And so this is going to be 12, and just find the factors of 12, make them into prime numbers. So I know 12 is 2 times 6. 2 is a prime number, so I can't change that one, but 6 isn't. 6 is 2 times 3. And then since it's a square root, not a cubed root or a root with a 4 in it, then I'm going to circle the pairs. It looks like we have in this one a pair of 2's. So I can pull out the pair of 2's. I'm going to pull it out to the outside 2. And underneath the square root, we have to leave whatever is left. In this case, I still have a 3 left. 2 square root of 3 is simplified. If we plug these numbers into the calculator, square root of 12 and 2 times the square root of 3, you should get the same decimal, the exact same decimal. Let's try another one. Let's try 40. Simplify this radical. So 40, I'm going to put just the 40, and I'm going to look at the prime numbers that go into 40. 2 times 20. 2 is a prime number, 20 is not, so I can simplify this one. The 20 can be simplified to 2 times 10. And the 10 can be simplified to 2 times 5. Now 2 and 5 are both prime numbers. We can only take out pairs. So if I look at the pairs, I have a pair of 2's that I can take out. And whatever I leave inside, if there's 2 numbers, I'm going to multiply them. 2 times 5 is 10. Remember, when we have a square root in the denominator, in order to rationalize our denominator, we're going to multiply the top and the bottom by the square root of 3. So 1 times the square root of 3 is just the square root of 3. Can't change that. The square root of 3 times the square root of 3, the square roots will cancel each other out, and I just get 3. And that's all I can do. I want you guys to try the rest of these and check them using the calculator. If you have questions, ask us. The Pythagorean theorem is very important. We're going to look at this a lot in this chapter to help us with our trig. It's a squared plus b squared equals c squared. Remember that the c is our hypotenuse. Okay, that's the biggest side. It's also the side that's across from the 90-degree angle. Okay, so c is going to be the side. I'm going to make it red. I'm going to try to always make it red. But c is the side that is across from this 90-degree angle. And we can only use this if we have a right triangle, which means that we have a 90-degree angle. We will only have one. So this one says find the length of the missing side. Well, we know that we need to use the formula a squared plus b squared equals, and then c squared. The a and b, it doesn't matter which sides you use first, a or b, but the c has to be the hypotenuse. So I'm going to try to always label the hypotenuse red. So this is my 90-degree angle. It kind of looks like an arrow and the arrow is pointing towards my hypotenuse, right? So this one is 13 is my hypotenuse. So we have 12 squared. Let me explain that. So the A and B, it doesn't matter which one you use. This one is 12, and they're asking you for the length of the missing side. So this one is just going to be x, or you can make it A or B. So I'm going to set it up. A squared plus B squared equals C squared. You guys see that on the top of your paper right here. And a little bit above that is the equation also. So it doesn't matter what we start with, the 12 or the x, but we cannot start with the C. So I'm going to start with 12 squared plus x squared equals 13 squared. 12, and then just simplify it. If you want, draw a line down that equal sign so that you can know that you're going to have to add or subtract those numbers. So we know that 12 squared is 144 plus x squared equals 13 squared is 169. Now, in order to move that 144 to the other side and solve for x, we're going to have to subtract it. And then we're going to get x squared equals 25. And then when we take, in order to get rid of the squared, right, we don't want the squared, we want just x by itself, we have to take the square root of both sides. And we're going to get x equals 5. So this third side is 5. And since they're all whole numbers, 13, 12, and 5 are whole numbers, this is called a Pythagorean triple. Okay, when a squared plus c squared equals c squared, and they're all whole numbers, that's a Pythagorean triple. So this is, give me an example of a Pythagorean triple. Well, 5, 12, 13 is a Pythagorean triple. All right, give me some more examples. Try some more sides out, and try number 2. It says, which of the following is a Pythagorean triple? Remember, if it is a Pythagorean triple, it has to follow the rule of a squared plus b squared equaling c squared. And remember that the c has to be the biggest side. So let's try this one in the middle. Oh no, let's try this one. So this is going to be my a and b. Doesn't matter which one I choose first, but my c has to be 5 because that's my hypotenuse. That's the biggest side. So I'm going to put 4 squared plus 3 squared equals, does that equal 5 squared? If it does, then that's going to be one that we can circle. 4 squared is 16 plus 3 squared is 9. Does that equal 5 squared is 25? And we're going to put a little question mark above here. We're trying to check. Does it equal? 16 plus 9 is 25. Is that equal to 25? Yes. Since they follow that rule, a squared plus b squared is c squared, we can circle this. This is a Pythagorean triple. And this is going to be a very famous one that we use a lot, okay? 3, 4, 5. It's a Pythagorean triple. Try to figure out some more. Go ahead and flip your paper over when you're done. Not all triangles are going to be right triangles, right? But if they're not, we're going to find out how to see if they're a obtuse triangle or an acute triangle. So if they follow the rule that a squared plus b squared equals c squared, then if they're equal, then it's a right triangle, right? But let's say that my c squared is bigger. That means that my hypotenuse is bigger than my sides, right? So say this is my hypotenuse, and these are my sides that are too small. That's a horrible triangle. Let me try using my rulers. So something like this. This is my hypotenuse, and these are going to be my, these are going to be my sides. I thought I could change the color. Okay, so in this case, my hypotenuse is bigger, and that makes this triangle, this is my hypotenuse and it's bigger, that makes this triangle an obtuse triangle. Obtuse, right here. Now let's say that my hypotenuse is too small. It's less than. So you see this is less than my sides. So my hypotenuse is not it's not a right triangle because my hypotenuse is too small. Maybe something like, can I change this color? Maybe I have something like this. And then I guess not. Something like this is an acute triangle. And also, if you have an equilateral triangle, all the angles are 60 degrees, that is an acute triangle, because we don't have a 90-degree angle, but all of my angles are less than 90 degrees. All of them are less than. Remember, an obtuse means there is one that is greater than 90 degrees. We've gone over this before, just wanted to remind you, and now we can prove it. If our hypotenuse is less than a squared plus b squared, then it is going to be an acute triangle. And this is an example of one. Okay, so we're going to use that information to prove that these triangles are a right, obtuse, or acute. I'm going to help you guys set it up. I know for sure that number 2 is an acute because if all my sides are equal, then all my angles will be equal, but I'm going to show you. So it doesn't matter in this case which one's going to be our A, B, and C since they're all equal. So I'm going to say is 5 squared. It's lagging. Is 5 squared plus 5 squared equal, less than, or greater than, and then 5 squared. So I can put, is it equal? I can put an equal sign in there. We're gonna find out if it's equal though. We're not sure. Alright, well, I know that 5 squared is 25, right? So I know that 25 plus 25, is that equal to 5 squared, which is 25? No, because 25 plus 25 is 50. Which one is bigger, 50 or 25? The 50 is bigger. So that means my hypotenuse, or my third side, is less than. Remember, if my third side is less than, then it's going to be acute. So you can go back up here. My third side is less than, so that's why it's acute. Okay, I want you guys to try the other ones. It says 3 lengths of a triangle that are given. Check if they form a triangle. Remember, if they form a triangle, then my 2 smaller ones have to add up to be greater than the third one. So I can put like A plus B has to be greater than C. If they form a triangle, use the Pythagorean theorem to determine whether they are a right triangle. If they do not form a right triangle, state whether the triangle is acute or obtuse. So let's look down here on this thing. All right, is it a triangle? My 2 smaller ones are 9 and 12. Is 9 plus 12 greater than 15? In fact, it is. 21 is greater than 15. So yes, it is a triangle. So we're going to say yes, it is a triangle. Now, my c squared, it has to be my biggest one. I'm going to make that red, remember? My biggest one squared. So this is going to be 15 squared. And then it says a squared plus b squared. I'm not going to make that red. Doesn't matter which one is your a and b. I'm going to put 9 squared plus 12 squared. Are they equal? Then it's right. So we know that 15 squared, you guys can plug that into your calculator. 15 squared is 225. And is that equal to, I'm going to put an equal sign, but we're not sure. We're asking ourselves, is that equal to 9 squared, which is 81, plus 12 squared, which is 144? And if you add those up, those also equal to 25. Are they equal? Yes. Then it is a right triangle. I like this little table we get to fill out. So is this a triangle? Let's do this one. 7, 12, 20. So 7 plus 12. Does 7, the two smaller ones, 7 plus 12, is that greater than 20? So 7 plus 12 is 19. 7, 19. Is that greater than 20? No. So it's not a triangle. This won't even make a triangle. So there's nothing else we can do. All right, let's try one more. 11, 10, 11, 15. So that one might not either. Let's try this one. 5, 4 squared root of 2, 7. My two smaller ones are probably, let's plug in your calculator. 4 square root of 2 is 5.6. So is 5 plus 5.6 greater than 7? So 5, I'm going to write it down. 5 plus 5.6568, right? Is that greater than 7? Yeah, that's like 10.6. So we're going to say yes. Perfect. This is at least a triangle. It might be not a right, but we'll check. So c squared. C has to be my biggest side, and that's 7. So we're going to say 7 squared, which is 49. Is that equal to a squared plus b squared? It doesn't matter which one I start with. I'm going to start with 5 squared plus 4 square root of 2 squared. The whole thing is squared, right? And 5 squared is 25. 4 squared of 2 is 4 squared is 16 times the square root of 2 squared is 4. 16 times 4. So 16 times 4 is 64 plus 25. So I know that this first one is 49 equal to the right hand side is going to be 89. Are they equal? Is that the same thing? No. In fact, my a squared and b squared are bigger. So my hypotenuse is small. I have a little baby hypotenuse like this, and that means that my triangle is acute. If you have a question, please just ask us. We're here and we're ready to help you. We would love to help you. And then we want you to try this out. I want you to try this by yourself. It tells you what to do in steps. Find the area of a triangle. They give you the formula for the area of a triangle, okay? This is your base right here, your base. And then this h is your height right here. You need to find out what your height is first, and it tells you that using the formula. First, use the Pythagorean theorem to find your height, and then just fill it into the formula. This is something that they will ask you on the SOL. All right, majors, we will see you in class. Have a great night.